two bodies of masses m1 is equal to 5 kilogram, so this is m1 5 kilogram, and m2 is equal to 3 kilogram, m2 is equal to 3 kilogram. A light string, okay, going over a smooth inclined plane, which means both of them, the coefficient of friction is 0. The force exerted by the inclined plane on the body of mass m1 would be, see, before we go any further, let me just write out this sentence here. The force exerted by the inclined plane, right? Force exerted by the inclined plane on what? On the body, on m1, right? On m1. Now see, what is the name of this force? Exactly, the name of this force is normal reaction. And how does the name comes up into pictures? Very simple. One component of weight is acting downwards from the body, it will act towards the surface, and since every force will have equal and opposite reaction, this action on the surface will be reacted, and that reaction is always perpendicular to the surface. Therefore, being perpendicular, it is normal, and being a reactive force, it is reaction, and therefore we have the normal reaction, which is normal reaction on the mass m1 due to this inclined surface S. Okay. Yes, some of you may have doubt here because you have skipped the explanation on resolution of weight. I have done it in the couple of for that matter, actually, for the past 5 questions, but for those students who are all first time here, we can do that one more time, no issues. So if this is the weight, if this arrow represents the weight, this can be resolved into two different vectors. One, sorry, give me a minute. One which is like this, right? And the other vector which comes like this. Which comes like this, right? So you have one vector mg which can be resolved into two vectors like this. One which is perpendicular, other which is horizontal, right? Now this horizontal vector can actually be taken away from this point, and it can be kept like this, right? And if I redraw this figure, what I have here is, this is mg, right? And we have one vector like this and another vector like this. So this is theta. Why? Because this angle is theta, so this will be also theta. And what will this be equal to? This will be equal to mg sine theta. And what will this green be equal to? This will be equal to mg cos theta. And now if we draw the various forces acting on this block, now see, whenever you draw the free body diagram, you have to keep one thing in mind. So when you draw the free body diagram of the specific block in this case this is m1, you should have always references for the external forces acting on the body and not the internal one. So all the external forces acting on this body m1 has to be depicted here. Now what is the primary force acting on this, external force acting on this body? That is weight. And since we're talking about the sigma fx, we're talking only about the horizontal forces. So we'll take the horizontal component of weight. This is weight, this is horizontal component of which is mg sine theta, and therefore we'll represent mg sine theta here. Now what is the direction of tension? See, since it is connected to a string, there will definitely be a tension element of tension in it. And what is the direction of it? The direction of tension would always be from the point of contact away from it, right? So that's the direction of tension. And since the object is in equilibrium, we can say that sigma fx is equal to 0, and therefore t is equal to mg sine theta, right? T is equal to mg sine theta. And what is theta here? Do we have the value? Theta is given to us as, we don't have an angle, right? Okay, we don't have an angle. So we have t is equal to, we can write t is equal to 5 into 10, 50 sine theta, right? Now what will be the case when it comes to sigma y? Again, for which body this is? This is for the body. This is body M1. We are considering only the F external, and when F external is considered, there are only two components. One which is weight. What is the vertical component of weight? Which is mg cos theta. Vertical component of weight is mg cos theta. And as we said very earlier, what is the force exerted by the inclined plane on M1? It will be the normal reaction. So it will be acting perpendicular to the weight, which is normal reaction on M1 to S. Now, since the body is in equilibrium here, we can say that sigma Fy is equal to 0, and therefore sigma F of y acting upwards will be equal to sigma Fy acting downwards. Which force is acting upwards? Nm1s, which is acting downwards, mg cos theta. So we can have that Nm1s is equal to 510 cos theta, which is normal reaction on M1 on S is equal to 510, which is 50 cos theta. Are we done now? No, we have to consider the block 2 as well. Okay, now when we consider block 2 is moving only in this direction, right? It is restricted to y axis. So I can write here that block 2, which is actually the mass M2, it is restricted along which axis? It is restricted along the positive y axis, right? Which otherwise means there is only the need to consider sigma Fy and not sigma Fxy, because sigma Fx is equal to 0. Well, I said sigma Fy is also equal to 0, but we consider only the sigma Fy. Why? Because there is no net direct motion along the x direction. Okay, right. Now, so this is the block here. What are the two external forces acting on it? What are the two F external acting on it? One is the force of gravity and the other is the force of tension. So we have gravity acting along M2G, the other is tension. So what we get is M2G. If sigma Fy is equal to 0, okay, maybe some of you get confused. So if sigma Fy is equal to 0, I can write that sigma F upwards should be equal to sigma F downwards. And what is sigma F upwards? The upward acting force is tension. What is F downwards? The downward acting force is M2G. So we have tension T is equal to 3 into 10, which is 30. So tension in the string is actually 30 Newton in this string. And this string is common across the entire system, which means the M1 will also experience a tension of T is equal to 30 newtons. Coming back to the first equation, what is T now? T is 30 newtons. So 30 newtons is equal to 50 into sine theta. Therefore 3 by 5 is equal to sine theta, and then therefore we have is equal to 50 into cos theta. Now see, if sine theta is 3 by 5, what is cos theta? Cos theta is 4 by 5. Therefore this is equal to 50 by 10 is 10, 50 by 5 is 10, 10 to 4, yeah, 40 newtons. So the force exerted here would be actually equal to 40 newtons.